So today, 19.1 and 19.2, we're going to talk about cross sections and solids of rotation and surface area, but of prisms and cylinders only. So a net is a diagram of the surfaces or faces of a three-dimensional figure that can be folded to form the 3D figure. So for example, this right here is a net of a cube. It has all 6 sides spread out, flat, so that you could see every single side that makes up the cube. So that is what a net is. And every single side is called a face. Okay, so this is a face, this is a face, this is a face. They're all faces. A cross section, we've discussed this in class before, right? Pretend that you're slicing up the figure to a bunch of little thin slices, like bread is sliced up, right? A cross section is a region of a plane that intersects a solid figure. Cross sections of 3D figures sometimes turn out to be simple figures such as triangles, rectangles, or circles. I did demonstrate this in class a few lessons back. But in this picture here, I have a cylinder, and it is being cut by this plane, right? Remember the word plane? And by being cut by it, right, they are touching here, all along this shape right here in the middle. That's where they intersect. And then that shape is a circle, and therefore the circle itself is a cross section. Example 1, name and sketch the solid that can be formed by the net. Okay, so here we have 2 nets, and if I were to actually put these nets together, like fold all the pieces and put it together, what would it be? What would it end up being? So hopefully for the first one, because of the 2 circles, you're like, oh, what's the only thing that has a circle on top and a circle on the bottom, right? And that would be a cylinder. Right? So circle on top, circle on the bottom, and then the rectangle is this part. Okay, so it makes a cylinder. This is the net of a cylinder, made out of 2 circles and 1 rectangle. So for B, I've got 3 rectangles and 2 triangles. So now if I were to fold this everywhere that there's a line, so like here and here and here and here, right? Fold that up, put it together, what would I end up with? And hopefully you're like thinking, well, let's see. There's 2 triangles. So probably one's the top and the other one's the bottom. Okay, so this is a triangular prism. Triangular prism. And put together, I guess I could draw it like this. There's one triangle. There's the other. And then the rectangles would connect. Oops. We all know I can't draw. Let's try to make that straight. Close enough. So there's my triangular prism. Or I could have drawn it standing up, right? A triangle top, triangle on bottom, and then connect, and connect, and connect. Okay, either way, triangular prism. Example 2, describe the cross section of each figure. So here I have 2 solids. They're both being intersected by planes. And so basically I have to describe what the intersection is going to look like. Okay, what is the shape that I get when the plane touches everywhere that the plane touches the solid. So for A, I have a cone. And the thing is, when it is intersected by a plane, the shape that is formed looks like this. This is the part where the plane would intersect the cone. Okay, so describe the cross section. The cross section would be a triangle. Just picture a cone. Slice it like a loaf of bread, bunch of little thin slices. Each slice is a cone. If you do it vertically, like this picture. B. So I have a cylinder. It's not standing up tall like this, right? But that's okay. So let's see. Everywhere that the what's this called? The plane intersects is right there. So what shape is that? And it is a rectangle, and that would be the cross section. Okay, above on the notes there, I had a cylinder earlier, but the plane was going this way. So because the plane was horizontal, the cross section was a circle. See here, um, my cylinder is not in the same position, it's laying down, so the cross section is a rectangle. Generating or creating three-dimensional figures. It is possible to generate a 3D figure by rotating something that is 2D. For example, if I were to take some weird shape, like uh, let's draw D. Let's say a B, something in the shape of a B. And I started rotating it, right, turning it over and over and over and over again. So let's rotate it this way. I'm rotating it over and over and over again. The idea would be that this two-dimensional shape could become three-dimensional by turning this a bunch of times, and I would end up with something that looks like this. And it would be circular, right? Just turn it, turn it, turn it, turn it, turn it. Well, that's the idea behind the next section here. So example 3, describe and then sketch the figure that is generated by each rotation in three-dimensional space. So A. So here we have a right triangle. They want us to rotate it around the line containing one of its legs. The line that we're going to use is this line called L. And so basically, they want me to take this triangle, this 2D thing, and they want me to rotate it around and around and around. And they want me to basically draw a little drawing, a little figure of what that looks like. Okay, so picture this. You have to be a little imaginative here. What does it look like? So pretend you have a triangle and you're just turning it and turning it and turning it over and over and over again to the point that it does become something 3D. Well, this is going to become a cone, right? It's going to turn, right? It's going to turn like this a bunch of times, and it's going to generate a cone. All right, B. A rectangle rotated around a line containing one of its sides. Okay, so again, we're using this line right here, line L. And they want me to rotate this over and over again around this line. So this is going this way, right? It's just turning and turning and turning and turning. Okay, so now what's going to happen? I have the rectangle and it's turning like this, top and bottom. It's turning, turning, turning. This line is also going all the way around, right? Turning, turning, turning. What shape does this make? It's going to look like this. It's going to be a cylinder. Okay, I don't know how to draw. But that's what happens when you take a rectangle and you rotate it around and around and around and around along the same line. So we're not moving it either. So basically, I went too far. Basically, from the middle to the middle. So here was my rectangle, and it just got turned, and then turned and turned and more turning. So here's the rest, you know, that's the other half. And then turned again, and then turned and turned, and it just keep turning, right? Starts to look like a cylinder. C, a semicircle. So here we have half of a circle. They want me to go this way, right? Oh, counterclockwise, clockwise doesn't really matter. I'm just going around. But I'm going around this part right here. So let's see. So this gets turned over this way and comes back around. Turn, comes back around, turns, comes back around, turns, comes back around, turns, turns. Oh, it's too much. Okay, let's do that again. Turns, comes back around, turns, 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 right? So what does it look like? Just flipping this. Ooh, ooh, ooh. Okay, and I'm hoping you're saying it's a sphere, because it is. Okay, I get a sphere. That's what happens when you have a semicircle and you rotate it along its diameter. Okay, next section. Surface area of any prism, or the surface area of a cylinder. So here are our new formulas. Surface area of a prism is perimeter times the height of the prism plus 2 times the area of the base. Please let's not forget big B stands for the area of the base. It's not just the base. Okay, there's a reason why it's capital. It's a capital letter to remind you this is the area of the entire base, whatever that may be. It's not just whatever the base length is. Lateral area. Lateral area is supposed to be the area, the surface area of a solid figure, but it does not include the top and the bottom. So if you notice, this part right here is that. That is the lateral area. So for a box, or something in the shape of a box, let me draw this real quick. Hee 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 hee. Okay, I'm not perfect, but you get it. So for a prism, lateral area would be this side, the front rectangle, the one on the side here. It would be the one on the back over here. Well, actually, let me go another direction. There you go. The one on the back. And then it would also be the one on the side, or sorry, on the other back side part. So it would be all of those, right? Oh, front. I need green. It'd be front, back, the two backs. It's everything except for the top and the bottom. So again, lateral area does not include the area of the top and the bottom. So this would not be included, and this would not be included, but it's everything else. So the two bases One counts for the top, the other one counts for the bottom. Lateral area is the other four sides. Again, P is the perimeter of the base. So instead of finding the area of the base all the time, we're now finding the perimeter too. So I would need these four lengths and I would add them up and that would be the perimeter of the base. Right? Surface area of a cylinder also has its lateral area, right? Because the cylinder looks like this. So for the lateral area, I wouldn't count the top circle or the bottom circle. Okay, lateral area is just the around part, which is basically a rectangle. Okay, remember back to the first example, I think it was, when we had to figure out what that net was for A, part A. C, remember C? Big C is the circumference. It's the perimeter of the base. It's just because it's a circle, it uses the word circumference. And again, this is the lateral area because lateral area does not include the area of the bottom and the top. Example 4, find the surface area of the prisms. Okay, so let's start off with just regular old box here. And now surface area is the perimeter of the base. So this is going to be the base. Okay, times the height of the prism. So here's the height of the prism. Plus 2 times the area of the base, because there is one on top and there's one on bottom. So here's the area of the base. If I find that area, I multiply by 2 because again, there's one down here and there's one up here. And that'll take care of the surface area, the area of every single surface, every single face. Let's see. So height is 3. I know that's 3. Right? The perimeter of the base. So this is 15 back or front up here. This is 15 back there. So 15 plus 15. If this side is 5 here, then this other side is also 5. So plus 5 plus 5. And we have 40. So the perimeter of the base is 40. 2 times the area of the base. Now, the base. To find the area, it's a rectangle, so it's length times width or base times height. But 15 times 5. So that is 75. So big B is 15 times 5, which is 75. So I'll just plug that right in there. And then I can use my handy dandy calculator or my brain, right? Brain's always the better option. I would prefer you just did this in your head. Oh, let me just move this over. So anyway, 3 times 40 is 120, or 3 times 4 is 12, add a 0. And then 2 times 75 is $1.50, right? 75 cents plus 75 cents. So I have 270. And that is centimeters, and because it is area, it is squared. Next example, example 5. Find the surface area and lateral area of the right cylinder. Write your answer in terms of pi and also round it to the nearest tenth. Okay, so I have a diagram here on the side, and I'm trying to break this down for you. Okay, this is the net of a cylinder. It has 2 bases, top and bottom, which are circles, and then the lateral area is just the rectangle in between that holds basically the 2 circles, right? In order to find the surface area, let me look at my formula. It's the circumference times the height, because circumference is basically this around, and that around is this. So this is my circumference. That's why they have 2 pi r. This is 2 pi r. And then, of course, still h. So the circumference times the height, that should get me the area of the rectangle, which is the lateral area, plus 2 times the area of the base, because there's 2 bases. 1, 2. And the bases are circles, so this is pi r squared. So that is the whole formula for the surface area of a cylinder. And then, of course, figure out what is what. What do I need? Look at the formula. What are the variables? I need an r and I need an h. I need a height and I need the radius. Well, here's the radius, right? 15. And here's my height. That is how tall the cylinder should be, if at least if it were standing this way, right? Just laying down at the moment. So plug those in. So let's see. We have 2 times pi times 15 times 58 plus 2 times pi times 15 squared. They want this in terms of pi and rounded. So first off, terms of pi means that in the end, when I'm done with my answer for in terms of pi, what should still be there? And I hope you're thinking, well, the pi should still be there. So 2 times 15 times 58, I get 1740 pi. So that is just this part right here. Plus 15 squared is 225, and 225 times 2 is 450 pi. And then let's put those together. So 1740 plus 450. Right, when you do in terms of pi, you don't actually put the pi in the calculator. You just do the numbers, right? So I have 2,190 pi. Now they want it in terms of pi and also rounded, so I do still need to find a decimal. So there's my first answer, right? My second answer is going to be me actually going ahead and doing, well, what is 2190 times pi? And we get this. Rounded to the tens place, right? Rounded to the nearest tenth, yes. So to the nearest tenth, this is 0.1. So again, this is what I got on the calculator, right? All these numbers. They want to the tens place, which means here, which means I only look at that number, which makes that one bigger because it's bigger than, well, it's a 5 or bigger, right? And the units here were what? What were the units? Meters. So we've got meters and squared, because this is surface area. And area is always squared. It's two-dimensional. You had to multiply 2 dimensions, ideally, to get area. All right, example 6. Find the surface area and lateral area of the prism. Oh, you know what? I just remembered. I'm sorry. We were supposed to find the surface area and the lateral area. Well, okay, this is surface area, the whole thing. But lateral area, what is lateral area? I told you it was the area except for the top and the bottom. The bases, no bases included. So honestly, we already did the work. Okay, this is lateral area, which means this right here, oops, which means this right here. Okay, my lateral area is 1740 pi. So I'm going to erase this here. No extra work is required. If you think about it, 1740 pi meters squared, that is this area the rectangle by itself. The only thing I'm gonna have to do is, well, plug that into the calculator and see what decimal you get. 1740 pi. I was almost forgetting to do this. And there you go. Here's my lateral area. We've got surface and lateral. Again, for lateral area, if you're finding the entire surface area, you're not really doing extra work because you'll already kind of need to do it. Okay, example 6, back to example 6. Find the surface area and lateral area of the prism. Okay, so this is a new prism. I haven't done one that has a base in this shape. I've done rectangular and triangular, square, right, cubes. We've done cubes, but I haven't done this shape. So, how you can tell which part or which side is supposed to be the base, or the base is, because there's two of them, should be the only shape that's different, right? For a triangular prism, it's the triangles. For a rectangular prism, honestly, it doesn't really matter. Just pick two and you'll be fine. But in this picture, these are my unique shapes, right? I've got only two of these. I have four of the other, which are rectangles. The rest are just rectangles. Now, what shape are these? So if you were thinking, or if you said out loud, okay, why can't I write? Oh boy, this is acting up. If you were thinking trapezoid, then you're correct. Okay, this is a trapezoidal prism. And then my bases are trapezoids. Surface area is the perimeter of the base times the height plus 2 times the area of the base. So the perimeter is going to be me adding this side plus that side plus that side. So we've got 2 plus 4 plus 4. Oh, I need the top side. Oh, the top side is the same as that. So since the other top is 8, then that means this is also 8. So I have 2 plus 4 plus 4 plus 8. So that's my perimeter. So let's see. 8 plus 8 is 16, 17, 18. So my perimeter is 18. All right, the height. Well, how tall is this prism? If this is the bottom or top, doesn't really matter, and this is the top. If these are the tops and the bottom, well, how tall should this be? And I hope you're like, oh, the 12, the 12. Okay, that is how tall this should be. That's the height of the prism. And then 2 times the area of the base, because there are two bases. There is a top and there is a bottom. Let me go ahead and get rid of some of this. Okay, so now the bases are trapezoids. And so we have learned how to do the area of a trapezoid. You probably don't remember the formula. So it's 1/2 times the height, and then you add base 1 and base 2, the top and the bottom of the trapezoid. That's how you find the area. So in order to figure out what big B is the area of the trapezoid. Okay, so I'm going to do it on the side column here. So 1/2 times the height of the trapezoid. How tall is the trapezoid? It is not 4, by the way. If you need to look at this picture better, that's fine. But it is not 4 because 4 is very much a slant height. And we don't deal with slant heights when it comes to the real height of something. If I ask you for slant height, then you better give me slant height. But if I don't, I want the real height, the perpendicular height, the height that is perpendicular to the base. So I need to know how tall this is like this. Now looking at the picture, I do see that I'm told on the trapezoid that's in the back that it is 3 however many units tall. So 3 is my height. That's how tall the trapezoid is. Okay, so this is 3. Now base 1 and base 2, that's the top and the bottom. Well, here's the top, 8. Here's the bottom, 2. So let's see. We have 8 plus 2, which is 10, times 3 times 1/2. Well, 3 times 10 is 30. And then, so what is half of 30, folks? I hope you said 15. So the area of the base, right, the area of each trapezoid is 15. So here we go. We're ready for some math. 18 times 12, probably going to need a calculator for that, right? Which is fine. It's not like I'm saying, well, what's 8 times 2? That's 216. And then 2 times 15 is 30. So we have 246. I don't know the units. I didn't provide you with any in the picture. So we're just going to go with 246 units squared. Now this is my surface area. But I was also supposed to figure out the lateral area. Okay, if you listen to the previous example, I'm not asking you to do more work. What is the lateral area? The surface area is every single surface. The area of every single face put together. Lateral area is just the areas of the stuff in between the top and the bottom. Like, I don't want the top and the bottom. I want everything else. That is what lateral area is. And looking at the formula, this is the area of the base. That means this is the area of the lateral faces. So I'm not asking you to do more work. This is the lateral area, and therefore it is 216. Okay, no more work required. So this is surface area. Lateral area is 216 units squared. Well, let me be patient and give some of y'all some time to write this down. Okay, so start on the worksheet, turn it in when done. If you get to finish it in class, great, awesome, better yet. If not, you have to take it home to finish it for homework. I suggest also for homework, keeping up with your summaries and keeping your notes organized. Also, if you need to see this video again, it is on Google Classroom. If you lose the notes, they're on Google Classroom. You can print them out at home. Please try to check Google Classroom. Help yourself while I am away.